from high-level architectural intent to executing deterministic code is a primary source of friction in modern agentic system design. Without a structured translation pipeline, engineering teams often mix foundational primitives with contextual design, causing the two to become indistinguishable. This mixing leads to architectural drift. Systems become inconsistent, and their behavior becomes non-deterministic once they reach a production environment. The Agentic Delivery Layer Model establishes a framework for governed system translation. It moves the system from canonical rules to executable reality using a predictable process. Each layer acts as a boundary. Decisions made in a lower layer constrain the possibilities above it. Enforcing these 4 distinct boundaries prevents downstream teams from reinventing architecture, ensuring the final output matches the original intent. We begin at the canonical base, the foundation layer. Here, the discipline is pure architecture. This is where the system's universal laws live. It provides the non-negotiable primitives that every downstream design must follow. This layer houses the core ontology, semantic models, and policy types, and vital runtime controls. The work here is architecture-heavy and cross-system. It is designed to be reusable across the entire enterprise, independent of any specific use case. To maintain consistency, no system-specific invention is permitted here. This layer exists solely to define rules that prevent drift. Establishing a stable canon first ensures engineering teams don't have to reinvent basic architectural models for every new project. The second tier is the design layer. At this stage, the focus shifts to system design. The primary role here is to apply the universal canon to a specific bounded problem or use case. This is where you define agent archetypes, interaction patterns, and decision boundaries. You are translating intent into a structured system. Importantly, these designs are created by assembling the primitives imported from the foundation layer. The restriction is functional. The design layer creates structural boundaries and workflows, but it does not define new primitives. Treating design as an assembly of existing rules ensures complex contextual systems remain anchored to the organization's core architecture. The third tier is the alignment layer. The discipline here is governance. This is the mandatory validation gate. It is where you prove the design is correct and safe before any build cycles begin. The process is iterative and adversarial. You use scenario simulations and edge case analysis to stress test the design's logic. We perform rigorous policy validation and risk analysis to ensure the system remains within governable boundaries under all conditions. This makes governance as infrastructure a reality. Alignment becomes a physical system property rather than an external oversight committee. This is also where stakeholder approval and assurance requirements are integrated directly into the system's definition. If alignment is weak here, runtime failure is a statistical certainty. It acts as a structural blockade against unsafe designs. The final tier is the execution layer. Here, the work involves detailed engineering specification. The objective is to produce deterministic specifications that are ready for immediate implementation. This produces highly specific outputs, machine-readable policy configurations, and fully defined protocol state machines. This is where you generate API contracts and execution packs based on the validated design. The goal of this layer is the complete elimination of conceptual ambiguity. These specifications are directly consumable by engineering teams or AI-driven code generators, removing the need for further interpretation. There is a core rule at this stage. If a specification cannot be executed immediately, it is functionally incomplete and must be sent back. Execution is not about conceptualizing new ideas. It is the process of stripping away vagueness until only a buildable reality remains. To see the true value of the framework, we look at the boundary lines separating these 4 layers. The first boundary, between foundation and design, separates canon from application. It ensures that the universal rules in the foundation remain distinct from the contextual problem solved in design. The second boundary, between design and alignment, separates the design from the proof. Design creates the structure, but alignment is solely responsible for validating that the structure is safe and correct. The final boundary sits between alignment and execution, separating the abstract concept from the tangible execution. Traditional pipelines often allow these 4 layers to blend together, creating ambiguous specifications that trigger systemic drift during runtime. When these layers are mixed, execution artifacts become non-deterministic, and the system's behavior becomes impossible to govern at scale. By enforcing these delivery boundaries, you transform agentic systems into consistent and scalable architectures that are predictable by design.